Hi, this is Dr. Mahmoud again here. We're speaking about quality advocates, and this is the last video for quality advocates. We will be covering Dr. Taguchi, who is known with the design of experiment, DOE, or experiment design. So it is well known for designing and experimenting with different factors to reach to the high quality. And what he said is saying, look into these factors to remove variation from the process. Statistically planned experiments can identify the setting of product and process parameters that reduce performance variation. So basically here, what he said, in any environment, in any settings for a process, look into the factors, the parameters that will help into removing the variation. And by studying these parameters, you can reduce the variation. And this is what is known as the loss function equation, or the loss function parameter. And the loss function helps designers to set product and manufacturing tolerances. So through this design of experiment, DOE will help to set up tolerances. There are four basic steps for design of experiment, and these, first of all, select the process, what product you would like to study, identify important variables, what the variables that we should look into it. Example for that would be maybe the thickness of the material. Is that a variable? Is this a factor that will impact the quality? How about the speed of the machine? Is it the faster that we run the machine, the more defects we'll have? So we need to keep experimenting and looking into these factors that will impact the quality of the product. And by removing or controlling these factors, we were able to remove the variation from any process. Number three, reduce the variation on the important variables through redesign, process improvement, and tolerancing. Again, once we study these factors, we need to improve the process by controlling these variables. Number four, open tolerances for unimportant variables. So if there's any unimportant variables, you don't have to worry about it. So for example, you found out after experimenting and process observing and time studies, you found out there's no need for training for specific machines. So maybe training is not important for a specific process. Anyone can do it. So this is, you could open these tolerances so you don't require a specific training. However, if you're dealing with a very critical machines and you need somebody to monitor these, you need somebody with a specific training. So the training could be an important factor in the process. So again, what we need to do is look for a process, study the process, find out these factors and parameters that will impact the quality of the process, control them through the redesign, retolerances, and other way. And the last one, if there is something not important to your process, you could open the tolerances for these unimportant factors. Here is a good uh, figure that will show you what's the loss function is, and how this scientist Taguchi, how Taguchi came up with the loss function. Let's take a look into this chart, and you will see that here's the target, the one in the middle. So let me try to use the pointer here. All right, so if we say this is the target right here in the middle, and we looked into the process and we found this is the upper specification limit and this is the lower specification limit. So what was in the past before this theory it was in the past the common thinking around specification limits that the customer is satisfied. We were thinking that the customer will be satisfied as long as we are within the specification limits. However, here's the good point. This is what the laws function. The the philosophy of the laws function is saying the customer will be satisfied as long as you are close to the target. If you moved away from the target, the customer will be unhappy and unsatisfied. And there is a level of unsatisfaction. So if you close to the target, that would be a slightly unsatisfied. If you are far away from the target, that would be extremely unsatisfied customer. If you are outside of the control limits, that will be completely unsatisfied customer. I will not deal with you. However, again, there is no sharp edge as this figure 5 that you see here. There's no sharp edge show you that after that edge, the customer will be unsatisfied. No, it is the variation. As the variation increase in the process, the customer will gradually, exponentially become dissatisfied. All right, let's take more examples. If the variation exceeds the limit, then the customer immediately feels dissatisfied. Okay, so your target is that what make the customer satisfied. Exceeding going away from the target, that make the customer unsatisfied. The specification limits are good, but does not mean that the customer will be happy. For example, if the lower limit is 10 and the upper limit is 20, then the measurement of 19.9, that will lead to customer satisfaction, while 20.1 will lead to a customer dissatisfaction. Again, this is the old theory. The old theory is saying as long as you are within the control limits, the customer will be happy and satisfied. But Dr. Taguchi came up with a theory saying, no, this is not the way that we measure the customer satisfaction. Customer will not be happy if you are away from the target. This is what Taguchi states that any variation away from the nominal, which is the target performance, will begin to incur customer dissatisfaction. As variation process increase, the customer will gradually become dissatisfied. So for example, in the example that we give here, if the measurement is 19.9, the customer will be dissatisfied more than measurement of 19.8. So because 19.8 is closer to the target, so the customer will be more happy in 19.8. However, the customer will be dissatisfied more if you give him a measurement with a 19.9. If the measurement is 20.1, the customer will be slightly more dissatisfied than the measurement of 19.9. So it is gradually, this is the whole point. It's not a sharp edge where you know exactly this is unsatisfied, this is satisfied. No, it's gradually goes in a gradually curve that will represent the customer unsatisfaction. All right, here is a good demonstration for the customer. I would like to start with the one on the right side, where you see that your target is here. The more you provide process on target, the less lose for you, the more customer will be happy. The more you are away from the target and the spread of the data away from your target, the target basically is in the middle on here. So I'm going to create a line, which is here is the target, the middle of here. So your goal is to provide a target. You have to provide a data in this middle right here. This is where you need to provide your measurement. Away from the target, the customer will be unhappy. The more you will lose the customers. On the left side, On the left side here, you will see that the most satisfied customer will be on day 5 for arriving this orange. If you if you give the customer an orange for day 7, will be not exactly satisfied. You are away from the target. Day 9 will be completely unsatisfied. Same thing if you give an orange that is not ready and it's not ready to eat. So on day 3, the customer will be not happy. Day 1 is not acceptable at all. So it's again the loss function that Taguchi came with is a very excellent point where there is no edge where you know where the customer is satisfied and not satisfied. The customer will not be satisfied as long as you are away from the target. With that said, that's the end of chapter 2, quality pioneers. We talk about different people who invented the quality science. We did talk about their contributions, and we appreciate all what they do. And now these tools became important tools that we use it on daily basis in the quality field. That's the end, and we'll see you in another video with the 7 quality tools and how we could implement these 7 quality tools. See ya.